This is a quick video to show how I'm going to test a coil for a small wind turbine. Um, I'm going to test one coil on one magnet rotor, and then I'll add a second magnet rotor for an axial flux air core design. This coil is 2 inches outer diameter, 7/8 inch inner diameter. It's 3/8 thick. It's wound with 200 turns of 22 gauge wire. With that data, a single test at a single RPM can kind of tell me everything I need to know about this setup. The magnet rotors are 4 inches in diameter. The magnets are 1/4 inch thick, N50 neodymium iron boron, and they're 1 1/8 inch diameter. First, I'll test with one rotor. Got an AC voltmeter here, and I'm going to run the test at exactly 400 RPM because we know that if I run at half the RPM, it would be exactly half the voltage, and because voltage is directly related to RPM. So if I double the RPM, double the voltage. Also, if I double the number of turns in the coil, I'll double the voltage. Of course, I'd have to use wire that's half the cross-sectional area, so I'd have 4 times the resistance. So just testing one coil is enough data to really know exactly how you need to wind your coil to get the desired voltage per RPM. I can use this up here for RPM, and I double check it with this digital laser tachometer. So I've actually got it set at exactly 400 RPM, or really close. And the dial on the mill is pretty close. So I'll move the coil in where we need it. And you can see the voltage climbing. We don't want to crash the coil into the... That's right where we want it. So 1.4 volts AC from that coil. So if one coil is giving me 1.4 volts, if I make a full stator, 4 coils should give me 5.6 volts AC. That would be 4 coils wired in series. And the total resistance then would be 6 ohms. We're looking at RMS AC voltage. If we were to rectify to DC, we'd be rectifying peak voltage. So peak voltage would be 7.84 volts. DC minus whatever losses are in the rectifier. Silicone diodes are about 0.7 volts usually. So we'd have to subtract 1.4 volts from that figure. So if I put a full wave bridge rectifier on a full stator here, I'd be coming out around 6.4 volts DC at 400 RPM with a full stator of 4 coils like this. And I've tested at different RPM just to prove science that if I double RPM, I double the voltage. And so the next experiment I'll do, but I know the results, is I'll double the flux and I'll add a second magnet rotor. Try not to drop my phone. Putting magnet rotors on a shaft like this is a little tricky. And I forgot, I need to put washers in there. We want to run a tight air gap. The magnets should be running as close to the coil as possible. That ought to run. Okay, we'll try same RPM. Last time we had 1.4 volts. So it's a little more than twice, and probably because it's straightening out the lines of flux. So we're at about 3 volts. So in this case, we can kind of slightly more than double all these with dual magnet rotors. We'd be up around 15 volts, maybe 16 volts peak voltage. So if I put a rectifier on this now, we'd see about 14 and a half volts DC at 400 RPM with 6 ohm resistance in the stator, which is pretty impressive. Just for fun, I'll show what happens with RPM. There's about 500 RPM. There's about 300. And that's about 200. And there's all the data. Anyhow, this is all loads of fun, and this is going to be for a little tiny windmill for education. Quite fun.